Hello class, sorry I'm not here today. My son's not feeling well, so you guys get a video of me instead of actually seeing me. We are going to be doing the Unit 10 Day 7 notes, so you should have that already open and ready to go. We're going to start talking about trigonometry. In general, today's stuff should be a lot easier than some of those special right things that we've been talking about. Um, what we're going to start talking about is eventually sine and cosine. We're going to talk about some of these key vocab words that are up here. One of them is called a reference angle. The reference angle is the angle in the triangle in which the problem is being based on. Typically, the reference angle is going to be one of the acute angles. Either in this triangle, it would be like angle L or angle D. The opposite leg is basically how it sounds. It's the leg that is opposite from the reference angle. So if we were talking about, let's say, angle D, the leg or the side that's opposite angle D would be this side, LE. So LE would be the opposite leg. Adjacent leg is, if you know what adjacent means, it means next to. It is the leg that is adjacent to the reference angle. So if we were talking about angle D, there's two sides that are right next to angle D. One of those sides is this side here, which is the hypotenuse, and then the other side is this guy. The one that's not the hypotenuse, that is the adjacent. So if we were talking about angle D, DE would be your adjacent leg. And then the hypotenuse, you guys already know what a hypotenuse is. It is the longest side of the triangle, and it's always across from the right angle. So in this triangle, the hypotenuse would be LD. So we're going to do some examples down here. Given the reference angle, label the sides of the triangle as opposite, adjacent, or hypotenuse. So the reference angle for this guy is angle B. So I'm going to just circle angle B. The hypotenuse is going to be the easiest one because we all know where the hypotenuse is. It's always across from the right angle. So this side is the hypotenuse. Then we've got opposite and adjacent. The opposite side is the side that does not touch angle B. So the opposite side would be this guy, side US. And then the adjacent side is the side next to angle B. While there's two sides that form angle B, one of them is already the hypotenuse, so the only one that's left is this guy, and this is your adjacent side. Oh, and by the way, if the notes go too quickly, you can always pause the video. I'm limited on the amount of time I can use on these notes, so if it gets a little rushed, you can always pause to keep up. Okay, for this guy, we got angle R. So here's angle R, and now we're going to label our sides. The hypotenuse is always across from the right angle, so we can call this guy hypotenuse. Then we've got the two other sides, opposite and adjacent. Opposite is the side that does not touch angle R, so opposite would be this side, CA. And then adjacent is going to be the side right next to angle R that isn't the hypotenuse, so it's adjacent. And this will be really important, knowing what opposite, adjacent, and hypotenuse is when we get into sine and cosine and tangent, which we will get to in a moment. Alright, so this one we've got given triangle BIK, name the leg of the triangle opposite angle B. So if we're talking about angle B, the leg or the side that's opposite angle B, so the side that does not touch angle B would be this side over here, which is IK, and we'll use our little segment symbol. Then if we're talking about, I'm trying to get to my eraser here. All right, then if we're talking about the next angle, K, all right, then we have the leg of the triangle opposite angle K. Well, the side that doesn't touch angle K is BI, which is right here. Then if we do this one, name the hypotenuse. Well, the hypotenuse is always the side across from the right angle, so that would be BK. This one, we got triangle SKT. Name the leg of the triangle adjacent to angle S. So here's angle S. Adjacent means right next to. It's either going to be this side, SK, or this side, ST. Well, ST is the hypotenuse. So the adjacent side cannot be the hypotenuse. So this is going to be your adjacent side. And so my adjacent side is going to be SK. I didn't spell hypotenuse right. Oops. Then we got the next one. Angle T. So here's angle T. Name the leg of the triangle adjacent to angle T. Again, adjacent's right next to, so it's either going to be this side KT or this side TS. Well, again, TS is the hypotenuse, so the adjacent side would have to be the other one, which is KT. Then we got name the hypotenuse. We know that. It's ST. So it looks like that. Let's go to the back. Now we got this guy, triangle WLK. Name the reference angle if the opposite leg is WL. So now it's kind of the reverse. We're given the leg, so here's my leg, WL, and we need to name the reference angle. Since it's an angle, it's either going to be angle W, angle K, or that's about it, because reference angles will not be the right angle, which is angle L. So it's either going to be angle W or angle K for your answer for all of these. We've got the opposite leg is WL. So is WL opposite angle K or is WL opposite angle W? And hopefully you can tell that WL is opposite angle K. So angle K is going to be my reference angle. Then we've got name the reference angle if the adjacent angle or the adjacent leg is WL. Well, if it's WL, we already know angle K is opposite that. So it's not going to be angle K, it's got to be angle W. W is next to that side, so it's angle W. Name the reference angle if the adjacent leg is KL. So now our focus is on this side of the triangle. And again, it's either going to be angle W or angle K. Well, if it's KL, W is across from it, so angle W would be opposite. Angle K is actually adjacent to. So this one's going to be angle K because it's adjacent to that leg. And then name the reference angle if the opposite leg is KL. Well, opposite angle or opposite KL is angle W, so angle W is going to be this one. Trigonometric ratios are the ratios that involve two sides of a right triangle. We have three trig ratios that we're going to need to know. All right, these are called sine, S-I-N-E, cosine, C-O-S-I-N-E, and tangent. We will be abbreviating those as sine. Sine will look like this, S-I-N, cosine will look like this, and tangent will look like this. But those are the three trig ratios we're going to need to know. Your new favorite word is SOHCAHTOA. SOHCAHTOA. This is kind of a little mnemonic device to help you remember what sine, cosine, and tangent are. Sine, cosine, and tangent are going to be ratios. They're going to be fractions. Sine is going to always be the opposite side over the hypotenuse. Hence why it's SOH, sine, opposite, hypotenuse. Then we've got cosine, CAH. Cosine is the adjacent side over the hypotenuse. So CAH. And then tangent, TOA. Tangent is opposite over adjacent. I'm going to abbreviate a little bit. So if we're talking about the sine of angle D, then the sine would be opposite over hypotenuse. Or if we're talking about the cosine of angle D, it would be the adjacent side over the hypotenuse. And so on. We'll practice it down here. So in this problem here, we've got these three sides, 8, 15, and 17. And we're going to be finding the sine, cosine, tangent of angle A. And then again, we're going to do it with angle C. So for angle A, we'll start off with that. With angle A, you're going to want to label all your sides. 17 is always the hypotenuse, no matter what, because it's always across from the right angle. Now, as far as angle A goes, the side that doesn't touch angle A is the 15. So that's going to be the opposite side. And then the third side that's left, that's your adjacent side. So when we're finding the sine of angle A, sine again is opposite over hypotenuse. So opposite of angle A is the 15, hypotenuse is 17. So you're going to do 15 over 17. If you can reduce, reduce. This one doesn't reduce, but if you can, do so. Cosine, you got adjacent over hypotenuse. So from this angle, the adjacent side is 8, hypotenuse is 17. 8 over 17. Adjacent has to go on top, hypotenuse on the bottom. Tangent is opposite over adjacent. So you're going to go opposite, 15 over adjacent, 8. 15 over 8 will be your answer. Now we're going to talk about angle C. So for angle C, we are going to end up changing things a little bit. For angle C, the side that doesn't touch angle C is now 8. So AB is now my opposite side, and 15 is now my adjacent side. The hypotenuse never changes. Now we'll do the sine of this angle. So the sine of angle C is opposite, 8 over 17. Cosine is adjacent over hypotenuse, 15 over 17. And then tangent is opposite over adjacent, 8 over 15. And then you're done. That's your answer. Same down here, except number 4, you'll notice that we only have 2 sides. We don't know what this side is yet. We have to find out what that side is. To find out what this side is, we're going to have to do Pythagorean Theorem. Remember that C is your hypotenuse, so 15 has to be C. So I'm going to do x squared plus 9 squared equals 15 squared. I'm going to have x squared plus 81 equals 225. We're going to get rid of the 81 by minusing it. We're going to get x squared equals 144. Square root it. X is going to be 12. So my missing side is 12. Once I know that, now it's exactly like the problem above. We're going to be doing the sine of angle D, and then the sine of angle F, and then cosine of each, and tangent of each. Let's deal with angle D first. So here's angle D. The hypotenuse we know is 15. The opposite side is going to be 9, the side that doesn't touch angle D, and then the only side left is my adjacent side. Sine is opposite over hypotenuse, so opposite 9 over the hypotenuse 15. This one can be reduced, so make sure you reduce it. You get 3/5. Then for cosine of angle D, we've got adjacent over hypotenuse, 12 over 15. So we're going to do 12 over 15 and reduce it. You get 4/5. Tangent of angle D is opposite over adjacent, so 9 over 12, and you reduce it, you get 3/4. And then for angle F, so now I'm going to undo some of this stuff. I know hypotenuse is staying the same, but the adjacent and the opposite are going to switch a little bit. F, the opposite side, is now 12, the side that doesn't touch it, and the third side, 9, is now my adjacent side. Now I can do my ratios. So sine is going to be opposite over hypotenuse, 12 over 15, which is 4/5 when you reduce. Cosine is adjacent over hypotenuse, 9 over 15. And you reduce it, you get 3/5. And then tangent is opposite over adjacent, 12 over 9, which is 4/3. Okay. We still have a couple more pages to go. I am going to stop the video here because I'm only allowed so much time. So this is the end of part 1, but look for the other link and do part 2. Make sure you watch part 2 in a second. All right, thanks.